Picture this. It's 1984, the Terminator is about to hit theaters, and people are already freaking out about robots taking over. DARPA is trolling around, pockets full of cash and hungry for military innovation that only AI-driven vehicles can satisfy. Meanwhile, over at Carnegie Mellon University, a group of researchers is quietly working on a project that catches their eye. It would lay the groundwork for modern neural networks and self-driving cars as we know it. No, it wasn't Skynet, but it was pretty groundbreaking for its time. They call it the NavLab. It's going to be a research laboratory to bring those DARPA goals to life and prove that driverless cars can have a place in the world of military application. Chuck Thorpe directs the lab, but the team is where the star power is. Enter Todd Yoakum and Dean Pomerleau, two nerds who, quite frankly, without them, I'm not sure I would have even been able to make this video. If you guys are out there somewhere in cyberspace and listening, I can't thank you enough. The videos you preserved from the NavLab projects gave a lot of information from a primary source that helped me visualize a lot of what your projects could do. Alright, back to the story. NavLab gets kicked off with funding from DARPA. The goal? Build a vehicle that can hit 80 miles an hour on the highway and navigate off-road terrain, all without a human driver. Ambitious? Absolutely. Impossible? Not for Dean and Todd. That goal came with a lot of funding and 10 years to pull off a dream straight out of science fiction. The first step in this journey was the Terragator, a small six-wheeled robot that looked like a cross between a golf cart and a Mars rover. It wasn't exactly glamorous, but it was a proof of concept. The Terragator could map its surroundings with camera and navigate autonomously, albeit at a snail's pace. It was like the training wheel for future NavLab projects. By 1986, the team had leveled up with NavLab 1, a modified Chevy van that looked like it had been hijacked by a mad scientist. NavLab 1 would be powered by an AI system named Alvin. Alvin isn't just a fancy acronym, it was a tiny neural network helping to drive the world's first autonomous vehicle. Think of it as the granddaddy of the Tesla autopilot, but with way less processing power and a lot more flair. Using a neural network consisting of only 3 layers, Alvin could process visual data and provide information to steer the van in real time. Alvin was trained on just over 1,000 computer-generated images of roads, which, if your brain is screaming at the thought of building a neural network on synthetic data, it's totally understandable. We did not always realize that models with fixed parameters built on synthetic data could lead to a decline or even eventual model collapse of that particular system. Alvin would later be trained on human-generated data with a bit of special augmentation to ensure that it was easily read by the system. And just like that, this itty-bitty AI was ready for its debut. Alvin's first test drives, well, let's just say they were a start. Loading up a bunch of computers with Alvin and a couple members of the team into the back of the NavLab 1, they took to the sidewalks of the university to put this thing to the test. Cruising down the road at 5 miles an hour, things were slow, but more importantly, they were working. It could only drive in straight lines on well-marked paths, and if the road curved too much or the markings were unclear, Alvin would get confused, and honestly, same, but by the end of this run, it could hit a blistering 30 miles an hour. There was even a demo where it could detect pedestrians, though NavLab did not initially come with fancy automatic braking software. That came later. In the modern AI scene, this kind of human intervention or AI working with human oversight is called human in the loop and comes in a lot of flavors. But that's a different video for a different day. Still though, imagine the excitement. An AI-powered van spotting a human. It was like the first time a baby takes a step, except this baby weighed several tons and had a neural network about as deep as a ham sandwich for a brain. Rewinding for just a moment, how did any of this really work? Behind the scenes, there were some seriously cool systems powering these vehicles, way more than just the baby of a neural network that was Alvin checking the camera for road lines. There was Ganesha, an obstacle tracking system that used sonar, radar, and even LiDAR to create a live updating map of obstacles in the environment. To guide itself better on the road, another real-time system known as YARF would handle intersections and turning since curves were visually more complex compared to straight lines. Then there was Stripe. This was a later development, which with the help of early GPS let human operators direct the NavLab vehicle using low bandwidth radio links remotely. It was like a point-and-click adventure game, except instead of slaying dragons, you were guiding a robot van down the highway. This update meant that NavLab didn't need a bunch of students crammed inside the van, except maybe to break. Last but not least, there was the Pan to See All, a pan-tilt camera mount that could look around curves. And yes, the name is as ridiculous as it sounds, and yes, the team clearly had a sense of humor. I mean, one of these systems was seriously called Raccoon, and it tracked taillights. But it was thanks to this whole ecosystem of programs and systems that NavLab vehicles ran like a well-oiled machine. At the heart of this all was the DAM Arbiter, that's the Distributed Architecture for Mobile Navigation. Think of DAM as the ultimate multitasker. It took in data from all the different modules and made sense of it all. All of the systems on board the NavLab were often built and ran in ways that meant they weren't directly compatible with the other systems. DAM acted like the converter that could read all of the output data from these various models and then make the final call. It even used a dynamic weight to prioritize certain data streams, which is fancy talk for it knew when to listen to Alvin and it knew when to trust a Yarv. This was all just the start for the NavLab 1, or it would have been if the poor mommy missile of a van hadn't been lost to a fire with some liquid from one of the systems began to drip into another computer that was on board at the time. As all of these systems were being built and tests were being run, the team needed to look at something tougher to house Alvin. By 1990, the Terragator was retired and the team rolled out NavLab 2, a more robust version of its predecessor. It was a modified US Army ambulance, something they'd have a lot harder time destroying this go-around. The team spends a decade refining their system, and it was time to show the world what they could do with it. After all, they had a job to do and some sweet DARPA money to do it with. NavLab 2 lives a life out of the spotlight, making improvements to NavLab 1 and its systems and ultimately showing that the failures of previous models could be overcome. My tinfoil hat theory here is that the spontaneous failure of the NavLab 1 left the lab in limbo, and the NavLab 2 managing to make it through its era without any major failures helped ensure the longevity of these projects. It offered improvements to the system it ran on, yes, but it also showed the potential for a bit of stability and predictability that'd be needed for the long-term development. When NavLab 2 was retired, it was quiet. It was so quiet, in fact, that unlike other NavLab vehicles, I wasn't able to figure out what happened to it. Since some of the researchers have been able to comment on where other vehicles ended up, but not this one, I find it probable that it's in someone's private collection right now. You'd think at this point we'd be talking about the NavLab version 3, but no, because why would we ever do something easy like that? 1995 brings to life NavLab 5, the crown jewel of this CMU laboratory. This wasn't just a glorified boo-boo bus with a bunch of computers bolted to it. No, NavLab 5 was a sleek, modified Pontiac sport minivan with the nickname of Ralph. The big moment comes in July, when NavLab 5 embarks on a cross-country journey dubbed No Hands Across America. The goal? Drive from Pittsburgh to San Diego, nearly 2,900 miles with as little human intervention as possible. Out of all those miles, NavLab 5 handled 98% of the driving on its own. The human operators only had to take over for about 50 miles. For the early 90s, this was nothing short of revolutionary. All of those systems, like Raccoon and Alvin, had come together to make NavLab 5 a force to be reckoned with. In closed tracks, it could hit 80 miles an hour, fulfilling DARPA's 10-year goal for autonomous vehicle development. It was a huge milestone, and it proved that autonomous vehicles weren't just a pipe dream. That being said, it did also lead members of the team to recognize that this tech just wasn't able to support the vision of the time. DARPA's honeymoon with NavLab 5 would not last forever. Where the project failed to find further interest from the military, the Department of Transportation was taking notice of the progress this laboratory out of CMU was making. So whatever happened to NavLab 5? We know where at least one of the other vehicles ended up, and unlike NavLab 2, we get some clearer answers here. Turns out, getting old Ralph outfitted with all of those new and shiny systems made it less than optimal for resale. NavLab 5 only has value as a museum piece, but it is instead put to rest in a scrapyard. I find this to be the biggest downfall of the whole Alvin and NavLab legacy, but I'm sure at the time it would have been hard to see the industry these projects would have helped give life to and the value they would have had to the broader community. So let's talk about why this retired military ambulance powered by AI deserves a spot in the Tech Hall of Fame. First, Alvin was one of the first systems to demonstrate the power of neural networks in real-world applications. At a time when most AI research was focused on theoretical problems, the NavLab team showed that neural networks could handle messy, unpredictable environments like roads. It laid the groundwork for modern self-driving cars, which rely heavily on deep learning and computer vision, technologies that owe a lot to Alvin's early experiments. Alvin also proved that autonomy was possible with limited computing power. The computer running Alvin had less processing power than your average toaster today. Okay, maybe not the toaster, but definitely less than your smartphone. I mean, it could process camera images and make steering decisions in real time. That's like running a marathon in flip-flops. It's impressive, but also a little bit insane. At the time, the lab relied on a Sun Microsystems workstation, which was state-of-the-art, but laughably underpowered compared to today's GPUs. Despite this, Alvin's efficiency in processing visual data and making decisions was proof of the ingenuity in its design. What started out as a quirky research project in the 80s has blossomed into a global industry that today is worth billions of dollars. Companies like Waymo, Tesla, and Cruise are racing to bring fully autonomous vehicles to the masses. And while their technology is light years ahead of the NavLab 5, the DNA of Alvin in these projects is still alive. Alright, think about it this way. Alvin was one of the first systems to use a super tiny neural network to focus on a slightly flexible but ultimately pretty rule-based task. If that sounds familiar, that's probably because it is, and for more than one reason. This is basically the modern micromodel, something that some companies will tout about as new and emerging tech, but in reality, it was a design flaw that, when properly navigated around 30 years ago, really helped to move the industry forward from its first AI winter. Dean, Todd, and the team at CMU weren't just building robots for the sake of it. They had a bigger mission the funding enabled: reducing deaths on the road. You know, that and drive around a freaking Humvee at school. The team ultimately got their wish and saw their safety systems onboarded as a standard by multiple manufacturers. Safety tools like lane keeping assist, blind spot detection, collision warnings, and even pedestrian detection. The NavLab team dared to imagine a world where cars could drive themselves. They believed that technology could make our roads safer, our commutes easier, and our lives better, and they were willing to spend years, decades even, chasing that dream. Or, you know, maybe they were just some young guys getting through school, never knowing that a goblin would be trying to ascribe meaning to every public statement they made almost 30 years later. These days, Dean Pomerleau is considered to be a leading expert in autonomous vehicles and machine learning. Public information by Mr. Pomerleau says that he's been enjoying the last 20 years teaching fish to swim. I'm not even sure if there's sarcasm in this, but hey, if you can teach cars to drive, why not teach fish to swim? Todd Yoakum went on to find his passion in cryptocurrency, and like others who worked on the first set of NavLab projects, he would steadily drift away from the field of autonomous vehicles and artificial intelligence. Of course, the road to autonomy hasn't been without its bumps. Even today, fully self-driving cars are still a work in progress. There are technical challenges, regulatory hurdles, and ethical questions that should be answered. But every time a Tesla changes lanes on its own or a Waymo taxi picks up a passenger, we're seeing the fruits of the work that started in a CMU lab over 30 years ago. So next time you hear about a self-driving car hitting the streets, take a moment to think about Alvin and the NavLab projects. Think about the Terragator puttering around CMU's campus, and about the NavLab 5 cruising around the country with no hands across America. Because while the future of autonomous driving is still being written, one thing is clear: we're standing on the shoulders of giants. And those giants? They drove minivans. That's gonna be it from me today. Remember to like, comment, and subscribe to see this channel grow. See ya, nerds!